What is time? One of the most fundamental yet elusive concepts in the universe. It governs everything, yet defies clear definition. Since the dawn of human curiosity, we've sought to unravel its true nature. Is it a constant force, marching forward, or a complex illusion woven into the fabric of reality? How we understand time shapes how we perceive existence itself. From the perspective of classical physics, time seems straightforward. It flows evenly, ticking away like the hands of a clock. Isaac Newton described time as an absolute and unchanging backdrop against which all events unfold. Time, in this view, is a steady river. Its current flows forward, unaffected by the events it carries. For centuries, this idea seemed intuitive. The past is behind us, the future ahead, and time itself an impartial observer to all that occurs. However, this view began to unravel in the early 20th century. Albert Einstein's theory of relativity shattered the Newtonian simplicity. Time was no longer absolute. It was, instead, intertwined with space, creating a four-dimensional fabric known as space-time. Time's flow could stretch or contract depending on speed and gravity, blurring the lines between past, present, and future. To an astronaut traveling close to the speed of light, time would slow down, a phenomenon known as time dilation. In this new reality, time is relative and the once fixed boundaries of past and future appear fluid. But relativity alone doesn't capture the full complexity of time. Enter quantum mechanics, the realm of the infinitesimally small, where particles behave in ways that defy classical logic. Time in the quantum world becomes even more mysterious. In this domain, particles do not move in a straightforward, predictable manner. Instead, they exist in superposition, occupying multiple states at once, until observed. In some interpretations of quantum mechanics, time itself could even be an emergent property, something that arises from deeper, more fundamental laws we have yet to fully understand. On a more philosophical level, time has been pondered as both a mental construct and an essential feature of the universe. Immanuel Kant argued that time, like space, is a lens through which we interpret the world. It's not something that exists independently of the mind, but is instead a framework our consciousness applies to make sense of events. In contrast, thinkers like Henri Bergson saw time as a fluid, subjective experience, something measured not by clocks but by the inner rhythms of our lives. Yet even with all these perspectives, we're still left with paradoxes. Does time flow, or is it just an illusion? Can the future influence the past, or is the direction of time a one-way street? Can time be reversed, or are we doomed to travel in one direction, toward the future? These questions not only challenge our understanding of the cosmos, but our place within it. The nature of time isn't just a scientific curiosity, it's a question that echoes deeply within our own existence. As we explore the mysteries of time in the chapters ahead, we'll uncover not just the paradoxes of physics, but the profound philosophical implications they carry. Is time merely a dimension, or is it something more? Something that shapes not only the universe, but our very experience of life itself. Why time only moves forward. Imagine a glass of water that slowly drips, then shatters, its fragments scattering across the floor. The pieces never spontaneously reassemble. The ice cube in your drink melts into liquid, never the reverse. This one-directional flow is what we experience daily. Time seems to move only forward, never backward. But why is this the case? Why does the arrow of time always point in the same direction, from past to future? The answer lies in the second law of thermodynamics, one of the most profound principles in physics. According to this law, the total entropy of an isolated system, essentially the measure of disorder or randomness, tends to increase over time. In simple terms, things move from order to chaos. This creates the arrow of time, pointing from past states of lower entropy to future states of higher entropy. Imagine a glass of water in a room. Over time, the heat from the water disperses into the surrounding air, spreading the energy more evenly. As this happens, the system becomes more disordered, and the entropy increases. The process is irreversible. Once the energy is spread out, it cannot be concentrated back into the water, and the system cannot spontaneously return to its previous state. This law gives time its unidirectional nature. We cannot unmelt ice, nor can we unscramble an egg, because the entropy in those systems has increased. This increase in entropy is a hallmark of the arrow of time. It's the reason why time's flow from past to future appears irreversible. It gives us the perception that time is always moving forward, never backward, even though the fundamental laws of physics, those governing motion and energy, are symmetric. They do not inherently prefer one direction over another. However, the second law of thermodynamics doesn't paint the whole picture. When we delve into the world of relativity and quantum mechanics, time's arrow becomes less straightforward. In Einstein's theory of relativity, time is part of the fabric of space-time, which bends and warps depending on the presence of mass and energy. This creates a dynamic relationship between space and time, but relativity doesn't dictate the arrow of time. In fact, time's flow appears more flexible under certain conditions. For example, near a black hole, time slows down due to intense gravitational fields, a phenomenon known as time dilation. The forward march of time slows, but it doesn't reverse. Instead, the experience of time changes relative to the observer's position. In the quantum realm, the arrow of time becomes even more ambiguous. Quantum mechanics describes particles that can exist in multiple states at once, existing in a state of superposition until observed. Time, in this sense, might not even be as continuous or linear as we perceive it. Some interpretations of quantum theory suggest that time may emerge from a more fundamental process, not governed by the strict unidirectional flow we experience. In this view, time could be just an illusion, a byproduct of quantum events that give the appearance of a flowing sequence when, at a deeper level, everything exists simultaneously. Despite these intriguing perspectives, the second law of thermodynamics still reigns supreme at macroscopic scales. The overall increase in entropy in closed systems keeps the arrow of time pointing forward, even as relativity and quantum mechanics reveal more flexible, fluid aspects of time on smaller scales. So, while time may appear to flow as a constant straight line, the forces that shape it are more complex than we might initially realize. Time's flexibility in relativity and quantum theories challenges our understanding of time's flow, yet the second law of thermodynamics provides a grounding, irreversible force that keeps our experience of time tethered firmly to the future. Time travel. From fiction to science, time travel has long been the stuff of fiction, a concept that ignites our imagination and allows us to transcend the limitations of time. From H.G. Wells' The Time Machine to the Back to the Future trilogy, stories of time travel have fascinated us, presenting a world where characters journey into the past or future with the flick of a lever or a flash of light. These stories often feature the timeless questions: what if we could change the past? What if we could glimpse the future? And, most tantalizingly, could we rewrite the course of history? In fiction, time travel is a plot device that allows characters to manipulate the very fabric of time, often to solve problems, undo mistakes, or explore what might have been. The implications are always immense. Imagine saving someone from death, preventing wars, or experiencing the end of civilization firsthand. Yet with all its allure, time travel in fiction remains bound by its narrative purpose, an interesting story tool with no expectation of scientific accuracy. However, time travel has not always been relegated to the realm of the fictional. In the early 20th century, The advent of Einstein's theory of relativity gave rise to serious speculation about its scientific feasibility. According to general relativity, space and time are part of a single, unified entity called spacetime, which can be curved by massive objects like stars and planets. This curved spacetime can, in theory, create loops, called closed time-like curves, that would allow time to fold in on itself, enabling travel to the past or future. In 1949, physicist Kurt Gödel introduced a solution to Einstein's equations that suggested the possibility of such time loops. His model described a rotating universe where, if one were to travel along certain paths, they could return to their starting point in both space and time. But this was not a model grounded in physical reality. It was simply a mathematical curiosity. The question remained, could time travel be more than a theoretical construct? As theoretical physicists continue to explore the fabric of space-time, the notion of time travel is no longer as easily dismissed. One popular idea is the concept of wormholes, shortcuts through space-time that connect distant points in the universe. If such wormholes exist, and if they could be stabilized and traversed, they might act as portals through time. Yet, despite the tantalizing possibilities as a major hurdle, the concept of exotic matter, a form of matter that would be required to keep these wormholes open, remains purely hypothetical. More recently, physicists have turned to the idea of time travel through the manipulation of quantum fields. Quantum mechanics introduces a much more flexible view of time, where particles can exist in multiple states at once. Could quantum entanglement, the strange connection between particles across vast distances, provide a clue for time travel? Theoretical work by physicists like Kip Thorne suggests that quantum fluctuations might allow for time travel to occur under extreme conditions. Yet even these models remain speculative, with no experimental evidence to support them. Despite these explorations, many scientists remain skeptical. Time travel, they argue, could violate fundamental principles of causality. If you were to travel back in time and alter an event, it could create paradoxes, like the infamous grandfather paradox in which you prevent your own birth. Such contradictions suggest that time travel may not be possible, or at least not in the way we envision. The journey from science fiction to theoretical science is a long one, but the possibilities are intriguing. While time travel has yet to move beyond the realm of possibility and into reality, the exploration of its theoretical foundations pushes the boundaries of what we know about the universe. In the next section, we'll dive deeper into the physics behind time travel, exploring the key principles that might allow us to one day traverse the rivers of time. Einstein's relativity. Time as a dimension. Albert Einstein's theory of relativity revolutionized our understanding of the universe, and at the heart of this revolution lies a profound shift in how we perceive time. Prior to Einstein, time was considered absolute, an ever-flowing, unchanging river that marched forward at the same pace for everyone, everywhere. This was the belief rooted in Isaac Newton's laws of motion, which governed the mechanics of the universe for centuries. Time, according to Newton, was a universal backdrop, ticking away in perfect sync, independent of space or any observer. However, Einstein's theory of relativity shattered this comforting, intuitive view of time. In 1905, his special theory of relativity introduced the concept that time is not a constant. Instead, time is relative. It depends on the observer's state of motion. This breakthrough came from the realization that the speed of light in a vacuum is always the same, no matter how fast you are moving. In a universe where light's speed remains fixed, our experience of time changes depending on how fast we are moving relative to something else. The most famous result of special relativity is time dilation. This phenomenon occurs when an object moves at speeds approaching the speed of light. To an observer at rest, the moving object's clock appears to tick more slowly. For instance, if an astronaut were traveling near the speed of light, their perception of time would slow down compared to someone on Earth. This means that if the astronaut were to return after what seemed like only a few years to them, they might find that decades had passed on Earth, a fascinating concept made possible only by the flexibility of time itself. Einstein's general theory of relativity, published in 1915, took this idea even further. It expanded the concept of relativity from objects moving at high speeds to the influence of gravity. In general relativity, space and time are woven together into a single four-dimensional fabric called space-time. Massive objects like planets, stars, and black holes warp this fabric, bending both space and time. This warping alters the passage of time itself. For instance, time passes more slowly the closer you are to a massive object, like Earth or a black hole, compared to being farther away from it. This effect is most noticeable near black holes, where time can be stretched to such an extent that it appears to almost freeze at the event horizon. The contrast between these two concepts, time as absolute and time as relative, is striking. Our everyday experience still aligns with the classical Newtonian idea of time as a steady linear force. We wake up, go to work, and experience time moving in one direction at a fixed pace. But special and general relativity reveal that time is anything but fixed. It bends, stretches, and varies depending on motion and gravity. The past, present, and future are no longer as rigid as once thought. In fact, events that happen at the same time for one observer may occur at different times for another observer, depending on their speed and gravitational field. This revelation forces us to reconsider not only our understanding of time, but our very experience of reality. Time becomes a dimension, much like space, rather than a mere ticking clock. As we move through space-time, we are not just traversing the space around us, but also moving through the fabric of time itself. Black holes and wormholes. Bridges to the past and future. The concept of black holes, regions of space-time where gravity is so intense that not even light can escape, has long captivated both scientists and science fiction enthusiasts. But alongside these enigmatic cosmic objects, another idea has sparked even more intrigue: the possibility of wormholes or shortcuts through space-time that could, in theory, provide portals to the past, the future, or distant regions of the universe. Could these cosmic tunnels act as bridges through time, offering the promise of time travel? At the heart of the wormhole concept lies the theory of general relativity, which suggests that space-time is not a static, unchanging backdrop, but a dynamic, flexible fabric that can be warped and curved by the presence of mass and energy. This warping creates gravitational effects, such as black holes, that bend space itself. In some mathematical solutions to Einstein's equations, space-time is bent to such an extreme degree that it forms a wormhole, a tunnel-like structure connecting two distant points in space-time. Think of it like folding a piece of paper so that two distant points touch. The wormhole is the shortcut, bypassing the space in between. If such a structure exists, wormholes could theoretically act as time portals. Instead of traveling across the universe, one could travel through a wormhole, reaching distant parts of space-time instantaneously. Even more tantalizing is the idea that these shortcuts could be used to travel backward or forward in time. Imagine entering a wormhole, traveling through it, and emerging at an earlier moment in history or in the distant future. The notion of time travel, once confined to science fiction, suddenly appears as a scientific possibility. However, the challenges to making wormholes a reality are immense. For one, wormholes are purely theoretical constructs at this point. There is no experimental evidence proving their existence. While general relativity allows for the possibility of wormholes, the conditions required to create and stabilize one are beyond our current technological capabilities. The theoretical equations governing wormholes predict that they would be incredibly fragile, collapsing instantly unless held open by a form of exotic matter, a hypothetical substance, with negative energy that could counteract the intense gravitational forces trying to close the wormhole. Without this exotic matter, any wormhole would collapse before anything could travel through it. Even if such exotic matter could be discovered or created, there's the question of scale. Wormholes, if they exist, might be microscopic in size, far too small to allow anything as large as a human being to pass through. While some theories propose that wormholes could be enlarged, the technological and energy requirements to manipulate space-time at such a scale are beyond anything we can currently imagine. Moreover, there are other paradoxes that wormholes and time travel introduce. The most famous is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never be born, leading to a logical contradiction. Some physicists argue that the universe may have built-in mechanisms to prevent such paradoxes, a concept known as the chronology protection conjecture, which suggests that time travel to the past is inherently impossible or self-correcting. Despite the theoretical possibilities, wormholes remain a speculative idea, largely confined to the realm of mathematics and imagination. Yet the exploration of black holes and wormholes opens up fascinating possibilities for the future of physics and our understanding of time. As we continue to study these cosmic objects, we might uncover more about the nature of space-time itself, potentially unlocking the secrets of time travel. The grandfather paradox and other conundrums, time travel, while a fascinating concept, brings with it a host of logical conundrums that challenge our understanding of cause and effect. Among the most famous of these is the grandfather paradox, a thought experiment that asks a simple yet profound question. What happens if you travel back in time and prevent your grandfather from meeting your grandmother, thereby preventing your own birth? If you were never born, how could you have traveled back in time in the first place to prevent your birth? This paradox creates a paradoxical loop that seems impossible to resolve, illustrating the fundamental issues that time travel introduces. The grandfather paradox encapsulates the inherent contradiction of changing past events. If an action in the past can alter the conditions that led to the time traveler's own existence, it seems that the very possibility of time travel would be erased. This leads to an inescapable logical loop where the traveler's actions both create and prevent the circumstances necessary for their existence. The paradox underscores the tension between the idea of free will, changing the past, and the seemingly deterministic nature of time, where events follow a fixed cause and effect chain. However, modern theories in physics offer potential solutions that might resolve or reframe these paradoxes, allowing time travel to coexist with logical consistency. One of the most compelling of these theories is the multiverse theory, which posits that for every possible action or decision, an alternate universe or timeline is created. According to this idea, if you were to travel back in time and change an event, you wouldn't erase your own existence. Instead, you would simply create a new parallel timeline in which your actions played out differently. In this new timeline, your grandfather may never meet your grandmother, but that would not affect the timeline from which you originally came. The original timeline would remain intact, while the new timeline unfolds according to the changes you made. This idea aligns with the concept of many worlds in quantum mechanics, which suggests that every quantum event leads to a branching of reality into different possibilities. In the context of time travel, this means that when a time traveler changes something in the past, they don't alter their own original timeline, but rather spawn a new branch of reality. This provides a Neat solution to the grandfather paradox. No matter what changes you make, you cannot erase your original reality or your own existence. The timelines simply diverge. Another possible resolution is the idea of self-consistency, or the Novikov self-consistency principle, which suggests that any actions taken by a time traveler in the past must be consistent with the timeline's original history. In other words, no matter what a time traveler does, they can never alter events in a way that would create a paradox. If you tried to prevent your grandfather's meeting with your grandmother, something would always intervene to ensure that the timeline remains intact, preserving the continuity of events. For example, you might find that your interference in the past is ultimately futile because some unforeseen event prevents you from ever carrying out your original plan. This principle effectively enforces the idea that the past cannot be changed in a way that would lead to logical contradictions. Despite these theories, time travel paradoxes remain unresolved in many ways, and some physicists argue that such paradoxes indicate that time travel to the past is simply impossible. The complexities of causality, free will, and the structure of space-time may preclude the possibility of traveling backward in time at all. The many worlds interpretation, MWI, of quantum mechanics, is one of the most fascinating and mind-bending ideas in modern physics. It proposes a radical shift in how we understand the nature of reality itself, suggesting that all possible outcomes of a quantum event, every possible reality, actually occur, each in its own separate parallel universe. This idea stands in stark contrast to the traditional deterministic view of the universe and carries profound implications for concepts like time travel. At its core, MWI challenges the conventional interpretation of quantum mechanics, which holds that particles exist in a superposition of all possible states until they are observed, at which point they collapse into one definite state. For example, if a particle is in a quantum superposition, it might simultaneously exist in multiple places until we measure its position, causing it to collapse into a single location. The standard interpretation of quantum mechanics leaves us with this paradoxical idea: the act of observation creates reality. However, the many worlds interpretation rejects this collapse of the wave function. Instead, it posits that when a quantum event occurs, the universe splits into as many versions of itself as there are possible outcomes. Each outcome exists in a different branch of reality, and every possible event or choice leads to the creation of a new parallel universe. In this view, when you make a decision or observe a quantum event, the universe doesn't collapse into a single outcome. Rather, it branches into multiple coexisting realities where each possible outcome plays out. For example, if you were to travel back in time and alter a key event, such as preventing your grandfather from meeting your grandmother, the many worlds interpretation suggests that you wouldn't erase your original timeline or reality. Instead, your actions would create a new branch of reality, one where your grandfather never met your grandmother, and, as a result, you were never born. The original timeline, with your birth intact, would continue to exist in parallel with the new timeline where your existence no longer takes place. This creates a branching, ever-expanding multiverse where every possibility plays out in its own separate universe. This idea offers an intriguing solution to the time travel paradoxes we've discussed earlier, including the grandfather paradox. Instead of the time traveler being trapped in a logical loop, any changes made in the past create a new timeline free from contradiction. The multiverse grows with each decision, branching into an infinite number of possibilities, each with its own version of history. In essence, time travel becomes less about altering the past and more about stepping into a different version of reality, where the past unfolded differently. In contrast, deterministic models of the universe offer a more rigid and unyielding view of time. In deterministic models, every event is the result of prior causes, leading to a fixed sequence of outcomes. If time travel were possible in such a framework, it would need to follow strict causal rules. Any changes made in the past would directly affect the future, leading to the paradoxes we discussed earlier. The deterministic universe does not allow for the fluid creation of parallel realities, and thus it struggles to accommodate the idea of time travel without causing contradictions. The many worlds interpretation, on the other hand, provides a way for time travel to exist without disrupting the overall fabric of reality. It opens up the possibility that time travel doesn't need to correct paradoxes or preserve a singular timeline. Instead, it allows for the existence of an ever-expanding multiverse, where each possibility is realized in its own universe, allowing for infinite timelines to coexist. Alternate realities. Can time travel split reality? The idea that time travel could split reality and create alternate timelines is a compelling notion, drawing on the mind-bending possibilities of parallel universes and the multiverse theory. If time travel were possible, could the act of changing an event in the past give birth to an entirely new version of reality? The potential for multiple timelines to coexist simultaneously opens up new avenues of thought, but it also raises profound questions about causality, existence, and the very nature of time itself. The concept of alternate timelines is rooted in the idea that the universe, rather than following a single, unchangeable timeline, might instead be capable of branching into multiple parallel realities with each decision, action, or event that deviates from the original path. According to the many worlds interpretation of quantum mechanics, every choice we make, every quantum event that could lead to multiple outcomes, results in the creation of a new branch of reality. In the context of time travel, this means that when a traveler journeys to the past and alters an event, perhaps preventing a crucial historical moment, it doesn't erase or fix the original timeline. Instead, it creates a new timeline, where that event unfolds differently, and this new timeline coexists alongside the original. For instance, imagine a time traveler goes back and stops an important invention from being created. In the new timeline, that invention never happens, and the course of history changes dramatically. Meanwhile, the original timeline remains intact, and the effects of the invention continue to unfold. The multiverse concept suggests that there would be no paradox or contradiction, just the branching of multiple independent realities where each version of events has its own path. One of the benefits of such a multiverse is that it offers a kind of escape from the rigid determinism of a single, unalterable timeline. It provides room for infinite possibilities where every decision leads to the creation of a new universe with its own unique history and future. For those interested in the idea of choice, free will, and alternate futures, the multiverse provides a tantalizing freedom. It would allow for the exploration of what-if scenarios on a grand scale. Could there be a reality where humanity never experienced war? Could there be a timeline where we've solved the mysteries of the universe? However, the existence of multiple realities presents significant challenges. One of the most pressing issues is the problem of causality. If time travel creates a branching timeline, then each branch is independent, yet still influenced by the past actions in the original reality. How would causality work when there are infinite timelines? Could actions in one timeline affect the future of another? And if time travelers have the power to change key events, would they inadvertently cause chaos in the multiverse, creating unintended consequences that ripple across realities? The existence of multiple timelines also introduces a philosophical dilemma. If every possible version of reality exists simultaneously, does that devalue our own? If there are infinite versions of ourselves, each experiencing a different reality, what makes our particular timeline significant? This challenges our traditional view of existence, where we understand our lives as singular, meaningful journeys within a fixed timeline. The multiverse implies that there is no ultimate single story, but an endless array of versions of ourselves, each playing out a different narrative. Moreover, the existence of alternate realities could also complicate our understanding of free will. If every choice leads to a new universe, can we truly claim to be free in any meaningful sense? The implications of such freedom are staggering, raising questions about the very nature of personal responsibility, morality, and fate. While the idea of multiple, branching timelines offers a rich tapestry of possibilities for time travel, it also introduces a cascade of challenges that extend beyond the realms of physics and into the domain of philosophy. Can we live in a world where every choice we make spawns infinite realities? And if so, what does that mean for the meaning of existence itself? Exploring temporal paradoxes in a multiverse time travel has long been a staple of science fiction, but when viewed through the lens of modern physics, it presents a host of potential paradoxes that challenge our understanding of causality and the flow of time. One of the most profound aspects of time travel is the risk of creating paradoxes, contradictions that arise when the past is altered in a way that prevents the future, or the traveler, from existing. These paradoxes, such as the infamous grandfather paradox, seem to defy logic, suggesting that time travel might be fundamentally incompatible with the structure of the universe. However, in a multiverse framework, these paradoxes may not be as problematic as they first appear. The multiverse theory, which proposes the existence of countless parallel universes, offers a way to sidestep the contradictions of time travel. Instead of altering a single linear timeline, actions taken in the past could create a new branch of reality, a separate timeline that unfolds independently from the original one. In this view, when a time traveler goes back and changes an event, the original timeline remains intact while the new timeline forms, branching off like a tree from the point of change. This model eliminates the need for paradoxes, as the changes made in one universe do not erode the integrity of the others. Each universe follows its own distinct course, allowing time travel to occur without erasing or contradicting the traveler's existence. For example, if a time traveler were to prevent their grandfather from meeting their grandmother rather than causing a paradox that erases the traveler's existence, the act would simply create a new timeline, one where the traveler was never born, but where the original timeline continues unchanged. In this multiverse model, time travel no longer results in a destructive loop or paradox. Instead, it becomes a means of exploring alternate realities, where each version of the universe exists alongside others, each with its own distinct history. This multiverse approach provides a potential resolution to the many dangers associated with time travel. By preventing paradoxes from affecting the original timeline, it makes time travel less perilous. The traveler can explore past events, alter them, and discover new possibilities without worrying that their very existence will be wiped out by a contradiction. The implications of this framework are vast. In theory, it would allow humanity to travel through time, not as a single journey into the past or future, but as a branching exploration of multiple potential histories and futures. However, while the multiverse theory offers a solution to the paradoxes of time travel, it introduces new complexities of its own. If time travelers can create an infinite number of alternate realities with every action they take, what does that mean for our sense of identity and responsibility? How can we account for the consequences of our actions when they lead to an ever-expanding web of universes? Moreover, as the multiverse grows and diverges, the dangers of unintended consequences, where small changes in one reality ripple out to cause significant effects in another, become ever more pronounced. The multiverse, in its vastness, presents a landscape of infinite possibilities, each with its own set of risks and rewards. While time travel in a multiverse framework may eliminate temporal paradoxes, it opens new doors to understanding the very structure of reality It invites us to consider the universe not as a fixed, unchanging entity, but as a constantly branching and evolving tapestry where every choice creates new worlds, new possibilities, and new insights. Through the lens of the multiverse, time travel may not just be a tool for exploration, it may offer profound insights into the true nature of existence itself, revealing the deep interconnectedness of all realities. Ethical dilemmas of changing. History, the concept of time travel, opens up an unprecedented realm of possibilities, an opportunity to rewrite the past, correct mistakes, and undo historical injustices. Imagine being able to travel back in time to prevent atrocities such as slavery, the Holocaust, or the bombing of Hiroshima. The potential to right historical wrongs would undoubtedly seem like an ethical imperative, a chance to prevent human suffering and alter the course of history for the better. Yet, the ability to change the past also raises profound moral questions that challenge our understanding of responsibility, the consequences of intervention, and the very nature of reality itself. One of the most compelling ethical arguments for time travel is the ability to undo historical injustices. If time travelers could step into key moments in history and alter events, say preventing wars, mitigating suffering, or averting catastrophes, could they, in good conscience, refrain from doing so? The moral weight of such actions would be immense. Preventing the genocide of an entire population or halting the destruction of a civilization seems to be an unquestionably good act. In many ways, the idea of going back in time to fix the world's greatest wrongs aligns with our deepest sense of justice and compassion. However, the moral complexities of such actions are not so easily solved. What right do time travelers have to interfere with history, especially when the consequences of their intervention may be far-reaching and unforeseen? Even the smallest change in the past could create ripple effects that are impossible to predict. By preventing one atrocity, a time traveler could unintentionally set off a chain of events that leads to other, potentially greater harms. The butterfly effect. The idea that small causes can have disproportionately large effects illustrates the potential dangers of meddling with time. For instance, saving a single life might alter the course of future events in ways that change the fabric of society, the economy, or politics in unpredictable ways. The world created by the time traveler's intervention might not be an improvement at all, but a distorted version of reality that carries new injustices and unintended consequences. Moreover, the act of altering history raises a fundamental ethical question. Should we preserve the natural course of events, even if it means tolerating suffering and injustice, or should we intervene to make the world better by our own standards? This is a question that touches on the concept of moral relativism. What might be considered a moral improvement by one individual or society could be seen as a catastrophic change by another. A time traveler might perceive preventing a war as a good deed, but what if their actions inadvertently prevent the birth of an important historical figure or the development of a groundbreaking technology? Would the benefits of eliminating certain harms outweigh the potential loss of progress or discovery that those same events led to? Another significant moral dilemma arises from the idea of erasing or altering reality itself. Changing the past could not only undo the suffering of past generations, but could also result in the erasure of individuals' lives, memories, and achievements. The lives and experiences of countless people might no longer exist in their altered form, leading to the obliteration of identities, relationships, and legacies. Does the end justify the means if it involves erasing the very fabric of reality as we know it? Is it ethically acceptable to sacrifice the continuity of existence for the sake of a perceived better future? In a world where time travel is possible, the ethical considerations would be vast and complex. While the ability to correct historical wrongs might seem morally compelling, the consequences of such actions could be far-reaching and ethically ambiguous. Time travelers would have to navigate a fine line between moral intervention and the dangers of altering the fundamental structure of reality. The moral responsibility of a time traveler would, therefore, be not just to prevent harm, but to carefully weigh the risks of every decision made in the past, understanding that even the best-intentioned actions could have unintended and irreversible consequences. The consequences of time travel on human progress. Time travel offers humanity the tantalizing possibility of shaping its future by altering its past. The idea of going back to prevent wars, diseases, or other catastrophes seems to promise a path to a utopia, a world without suffering where progress unfolds more smoothly and humanity achieves its highest potential. However, while the ability to change the past offers the allure of a perfect world, it also carries the risk of unintended consequences that could distort human evolution and progress in ways we cannot predict. On the one hand, time travel could, in theory, accelerate human progress by eliminating barriers to knowledge and innovation. What if we could prevent pivotal setbacks in scientific discovery, such as the burning of the Library of Alexandria, or prevent technological stagnation during the Dark Ages? Time travel could enable humanity to fast-track its understanding of physics, medicine, and the natural world, potentially ushering in an era of unprecedented enlightenment. Diseases could be eradicated before they spread, and breakthroughs could occur centuries earlier, advancing civilization at a pace never before imagined. Furthermore, the opportunity to undo historical injustices such as slavery, colonization, or genocide would seem to promise a world of equality, peace, and justice. By preventing these atrocities, we might create a society built on fairness and compassion, leading to a utopia where humanity thrives without the scars of its past mistakes. In theory, time travel could serve as a corrective force, shaping history, to provide future generations with the best possible starting point. However, the consequences of tampering with history are far from straightforward. Even small changes in the past could have massive, unpredictable effects on the future. The butterfly effect, a phenomenon in which even the tiniest action leads to dramatic consequences, suggests that every intervention in the past could fundamentally alter the trajectory of humanity in unforeseen ways. By saving one life, we might inadvertently prevent another crucial event from happening. A single shift in the timeline could lead to the emergence of different technologies, political systems, or social structures, potentially creating a dystopia rather than a utopia. Moreover, the very act of altering history might stunt the natural progression of humanity. If humanity were able to perfect its past through time travel, might it remove the essential struggles that have driven human innovation and growth? Overcoming challenges, whether they are natural disasters, wars, or economic crises, has always been a driving force behind human creativity and resilience. By smoothing out these rough patches, we might unintentionally rob future generations of the opportunity to learn, adapt, and evolve. Without adversity, could human progress stagnate? Would we lose the drive to innovate if we could always avoid the challenges that force us to grow? Another critical issue is the unknowability of the future. While time travel may allow us to alter the past, it cannot predict what will happen next. The future is inherently unpredictable, shaped by countless variables that we cannot control or foresee. Even with the best intentions, altering the past could lead to a future that is entirely different from what we expect, and not necessarily for the better. What if preventing one catastrophe in history leads to the rise of a far worse one in the future? The future's complexity and uncertainty mean that time travel, rather than creating a perfect world, might simply create a series of new problems that humanity is unprepared to face. In contrast to the idea that time travel could lead to a utopia, the unknowability of the future makes the pursuit of perfection through time travel inherently flawed. As much as we may want to prevent harm and suffering, we can never predict the full consequences of tampering with time. The future remains an unpredictable, ever-evolving mystery, no matter how much we might try to shape it. Preventing a time traveler's paradox: can we ever be ready? The notion of time travel has captivated humanity for centuries, yet the reality of actually implementing it presents a host of uncertainties, both technical and ethical, that we may never be fully prepared for. The ability to travel through time offers the potential to alter history, explore alternate futures, and even prevent disasters. But with such power comes immense responsibility. Can we ever truly be ready for the ethical dilemmas and paradoxes that would arise from time travel? And more importantly, could we ever develop the frameworks necessary to navigate the consequences of altering the past? First, consider the technical side of time travel. While theoretical physicists have explored the concept through the lenses of relativity and quantum mechanics, the reality of creating a functioning time machine is still beyond our reach. Current scientific understanding, particularly in terms of wormholes, exotic matter, and space-time manipulation, suggests that time travel may be possible in some form, but only under extreme, currently unattainable conditions. Even if we were to one day develop the technology to travel through time, we would still face monumental challenges in ensuring that the process is controlled, predictable, and safe. However, even if time travel becomes physically feasible, the ethical considerations surrounding its use pose an even greater challenge. Unlike any other form of technological advancement, time travel involves the potential to undo, alter, or create profound changes to the past and the future. The very act of changing a single event in history could lead to an unpredictable cascade of consequences, not only altering the course of future events but also destabilizing the delicate balance of the present. The ethical implications are far-reaching. Who decides what should be changed? What if a time traveler with good intentions inadvertently causes harm in another timeline or universe? Could they be held accountable for their actions, especially if the consequences of their interventions are unforeseen or catastrophic? In this sense, time travel would demand a new level of moral responsibility, one where even the smallest actions could have ripple effects that affect the lives of millions. In a world where time travel is possible, the ability to determine right from wrong becomes infinitely more complex. One possible approach to preparing for time travel's ethical challenges is to establish strict guidelines and oversight. This could take the form of governmental or international regulations, similar to the way we manage nuclear weapons or advanced technologies today. Some propose the creation of a time travel council or a governing body that would assess the potential impacts of any time travel mission and regulate who can access time travel technology. Such a system could, in theory, ensure that time travelers are held accountable for their actions and prevent catastrophic changes to history. Yet in reality, this system of oversight may be flawed from the outset. The nature of time travel, particularly if it is based on multiverse theory, could create countless timelines, each with its own set of rules and consequences. How could we possibly regulate something so vast and unpredictable? How can we even ensure that the knowledge of time travel is kept from those with malicious intentions who might seek to manipulate the past for personal gain? Moreover, the uncertainty surrounding the consequences of time travel poses an insurmountable challenge. While we may attempt to predict the outcomes of changes to history, there will always be elements of the future we cannot foresee. As with all great technological advances, the risks associated with time travel are, by nature, unknowable until they are realized. Even with the most careful preparation, the ethical and practical challenges would be beyond our full understanding, as the unforeseen consequences of time travel would likely reveal themselves only after they have already taken place. Ultimately, the question of whether we could ever be ready for the responsibilities of time travel may remain unanswered for the foreseeable future. As time travel remains a theoretical possibility, we are left to wrestle with the immense ethical, philosophical, and practical challenges it presents. Would humanity be able to navigate the complex web of responsibility that comes with altering time, or would the dangers of unpredictability render such power far too risky to wield? The true test may lie not in our ability to invent time travel, but in our capacity to responsibly wield the power of the past and future. Is time travel possible? According to modern physics, the question of whether time travel is possible remains one of the most tantalizing and profound inquiries in modern physics. While time travel has long been a staple of science fiction, it has also found a place within the realm of serious scientific discourse. From the classical views of time as a linear progression to the more speculative quantum possibilities, the concept of time travel has evolved significantly over the years. In this section, we'll explore the scientific theories and experiments currently exploring time travel, contrasting classical physics with the quantum frontier, and examining whether time travel is a feasible reality. In classical physics, time was once viewed as a constant, unchanging backdrop for the events of the universe. Sir Isaac Newton's laws of motion and his concept of absolute time held that time flowed evenly and predictably for everyone, everywhere. This view aligned with the common experience of time as a steady, linear progression. The past leads to the present, and the present leads to the future. However, this view began to unravel with the advent of Albert Einstein's theory of relativity, which radically altered our understanding of time. Einstein's special theory of relativity, 1905, showed that time is not absolute, it is relative to the observer. According to relativity, the faster an object moves, the more time slows down for it relative to a stationary observer. This phenomenon, known as time dilation, has been experimentally confirmed with atomic clocks flown on jets or placed on satellites. For example, astronauts traveling near the speed of light would experience time passing more slowly than people on Earth. However, while time dilation is a well-established consequence of relativity, it does not constitute time travel as popularly imagined, i.e., traveling into the past or future. Time dilation simply shows that time's passage is not uniform across different observers, depending on their motion or position in a gravitational field. Einstein's general theory of relativity, 1915, further altered the understanding of time by incorporating gravity as a warping of space-time. Massive objects like planets and stars curve space-time, and this curvature affects the flow of time. The stronger the gravitational field, the slower time moves. Near a black hole, for example, time would appear to come to a halt for an external observer as the gravitational pull increases. General relativity also predicts the existence of closed time-like curves, CTCs, theoretical paths in space-time that could allow an object to return to its own past. These CTCs have been explored in mathematical models of rotating black holes, Kerr black holes, and wormholes, which are hypothetical passages through space-time that could potentially connect distant points in time and space. While classical physics lays the foundation for understanding the geometry of time, quantum mechanics opens up more speculative possibilities for time travel. Quantum theory suggests that at the smallest scales, particles do not follow predictable paths, but instead exist in a state of uncertainty, occupying multiple states at once. This introduces the idea that time might not be as linear or continuous as it seems on macroscopic scales. One of the most intriguing quantum possibilities is quantum entanglement, where two particles become correlated such that the state of one particle instantaneously affects the other, no matter how far apart they are. This has led some theorists to speculate that quantum entanglement could enable some form of faster-than-light communication or even time travel. However, these ideas remain highly theoretical, as quantum entanglement does not violate causality in a way that would allow information to travel backward in time. Another quantum theory related to time travel is the many worlds interpretation of quantum mechanics, which posits that every possible outcome of a quantum event creates a branching reality or parallel universe. In the context of time travel, this suggests that traveling back in time might not alter the original timeline, but instead create a new branch of reality where events unfold differently. While this interpretation provides a possible framework for avoiding time travel paradoxes, it remains speculative and is not universally accepted within the scientific community. Modern physics continues to explore the feasibility of time travel, particularly through the study of wormholes and exotic matter. Wormholes, as predicted by general relativity, are theoretical shortcuts through space-time that could, in principle, allow travel between distant points in time and space. However, wormholes would require exotic matter with negative energy to stabilize them and prevent them from collapsing. While researchers have proposed theoretical models for how wormholes could be formed, there is no experimental evidence that they exist, and the technology to create or manipulate them remains far beyond our current capabilities. Similarly, time travel into the future through time dilation, as predicted by relativity, has been demonstrated experimentally, but traveling into the past remains a significant challenge. The possibility of traversing closed time-like curves or manipulating space-time on a large scale is still a subject of theoretical investigation, with no clear experimental path forward. While modern physics has made tremendous strides in understanding the nature of time, the reality of time travel, particularly traveling to the past, remains elusive. The theories of relativity offer fascinating insights into the malleability of time, while quantum mechanics hints at the potential for strange, alternate realities. However, despite these theoretical advancements, the technical challenges and paradoxes associated with time travel mean that it is far from being a practical reality. As research in physics progresses, time travel may remain a tantalizing concept, not just in fiction, but as a cornerstone of future scientific inquiry. Technological barriers to time travel, once the domain of science fiction, has captured the imagination of physicists and technologists alike. While theoretical models in physics suggest that time travel might be possible under certain conditions, the technological barriers to making it a reality are monumental. Achieving time travel would require breakthroughs in both our understanding of the universe and our ability to manipulate it, particularly concerning energy requirements, space-time manipulation, and quantum phenomena. These barriers, while immense, are also what fuel speculative ideas about futuristic technologies like time machines and quantum computers, which might one day unlock the door to time travel. One of the most significant technological hurdles in achieving time travel is the energy required to manipulate space-time itself. According to Einstein's general theory of relativity, time is not a fixed, independent entity, but is intertwined with space in a four-dimensional fabric called space-time. To travel through time, we would need to manipulate this fabric, and doing so on a meaningful scale would require an enormous amount of energy. For example, one of the most popular theoretical concepts for time travel involves wormholes, hypothetical tunnels through space-time that could connect distant points in time and space. While the mathematics of general relativity suggest that wormholes are possible, they would require exotic matter with negative energy to remain open. This exotic matter would counteract the immense gravitational forces trying to collapse the wormhole, but no such material has ever been observed. Furthermore, the amount of energy needed to create, stabilize, and maintain a wormhole could be astronomically high, far beyond what we are currently capable of producing with today's technology. Even if we could create a stable wormhole, another significant challenge would be navigating it. To travel through a wormhole, we would need to control not just its stability, but also the gravitational fields that shape space-time. In theory, this would require the ability to manipulate matter and energy on a scale that is currently unimaginable. At present, we are nowhere near achieving the technology required to control such immense forces, and the energy demands would likely dwarf anything achievable by current power sources. In addition to space-time manipulation, quantum mechanics presents its own set of technological challenges when it comes to time travel. Quantum phenomena, such as entanglement and superposition, suggest that the nature of time itself may be more fluid and flexible than we currently understand. However, the practical application of these ideas is still in its infancy. For example, quantum computers, machines that leverage the principles of quantum mechanics to process information at an exponentially faster rate than classical computers, are an exciting area of research, but they are still in the early stages of development. While quantum computers might one day unlock new insights into the fabric of space-time and potentially even aid in time travel, they are currently limited by technological constraints such as decoherence and error rates, making them far from practical for anything beyond niche applications. Looking toward the future, the idea of a time machine, perhaps the ultimate tool for manipulating time, remains a speculative dream. In various forms of science fiction, time machines are often depicted as devices capable of traveling instantaneously through different points in time. In theory, such a machine would need to harness and control vast amounts of energy, possibly tapping into advanced concepts like quantum entanglement, exotic matter, or even harnessing the power of black holes. However, the very nature of these speculative machines remains far beyond our current understanding of physics. The engineering of a time machine would not only require breakthroughs in energy generation and control, but also an understanding of how to navigate the complex relationships between space, time, and the universe at large. Quantum computers, with their ability to model complex quantum systems, might play a pivotal role in this process. If we could achieve the computational power to simulate space-time at quantum levels, it might provide insights into how time travel could be practically achieved. Yet even quantum computing remains an immature field, and its potential applications in time travel are speculative at best. Currently, the technological barriers to time travel are insurmountable, not just because of the immense energy and scientific knowledge required, but also because the laws of physics as we understand them seem to limit our ability to manipulate time directly. Theoretical physics offers intriguing possibilities, but practical, real-world applications remain out of reach. The energy required to alter space-time on a large scale, the need for exotic materials and control mechanisms, and the quantum uncertainties all present significant hurdles. While the concept of time travel excites the imagination, the technological barriers remain substantial. Theoretical breakthroughs in physics, particularly around concepts like wormholes and quantum mechanics, might one day pave the way for practical time travel, but we are still far from having the tools and understanding to make it a reality. As technology progresses, new possibilities may emerge, but for now, time travel remains firmly within the realm of speculation and futuristic thought experiments. Temporal exploration, a new era for human evolution. The possibility of time travel could usher in a new era for humanity, one where the boundaries of exploration and expansion stretch far beyond the confines of space. Time travel, if ever achieved, could open up untold opportunities for human growth, understanding, and discovery. Rather than exploring distant stars or planets, humans could explore the very fabric of time itself, traversing the past, visiting future worlds, or even reshaping the course of history. However, while the potential for temporal exploration offers profound advancements, it also carries existential risks that could fundamentally alter the course of human evolution and existence itself. The promise of temporal exploration: if time travel were possible, humanity would gain access to an entirely new dimension of exploration. the implications for human evolution are vast. Imagine the opportunity to witness firsthand the defining moments of history, meeting influential figures from the past, experiencing ancient civilizations, or observing the dawn of human innovation. Time travelers could directly participate in shaping the future, preventing wars, eradicating diseases, or accelerating scientific discoveries. The capacity to prevent historical mistakes could lead to a more harmonious world, free from the scars of war, injustice, and ignorance. Time travel could also offer unparalleled opportunities for learning. Instead of relying solely on historical texts, archaeological digs, or second-hand accounts, humanity could observe past events as they happened. The mysteries of ancient civilizations could be unraveled with absolute certainty. Lost knowledge, such as that of long-forgotten technologies or scientific principles, could be rediscovered, potentially accelerating progress in areas like medicine, energy, and space exploration. The future, too, could offer glimpses into technologies, societies, and environmental conditions that could guide decisions in the present, allowing humanity to navigate challenges like climate change or resource scarcity with foresight. Furthermore, time travel could lead to profound cultural exchange across eras. People from different historical periods might interact, exchange ideas, and learn from each other. This blending of cultures, if done responsibly, could create a society rich with wisdom from every corner of time. Temporal travel could thus become not just a tool for exploration, but a means for enriching human experience, fostering empathy, and expanding the collective human narrative. However, the ability to alter the past and future presents existential risks that could dwarf the potential benefits. Even small changes in the past could create a cascade of unpredictable effects, known as the butterfly effect. A time traveler's attempt to prevent a tragedy could result in unintended consequences, perhaps leading to even worse outcomes or altering the very events that shaped human civilization in the first place. The idea of correcting history assumes that we understand the full scope of its consequences, but in reality, we cannot foresee the full impact of our actions in a web of interconnected events. One seemingly insignificant intervention could unravel the fabric of reality itself. The danger of creating paradoxes is another risk. What happens if a time traveler changes something so critical that it prevents their very existence or the existence of the timeline they originated from? The grandfather paradox, where actions in the past erase the time traveler's future, highlights the potential instability inherent in time manipulation. The very fabric of causality, the chain of events that shapes reality, could be undermined, leading to catastrophic, perhaps irreparable consequences. Moreover, the moral implications of altering history are profound. Time travelers might be tempted to reshape the past in their own image, removing unpleasant events, erasing suffering, or forcing society toward a particular vision of progress. This kind of manipulation could violate the autonomy of past generations and the natural course of evolution. It raises the ethical question: should humanity be trusted with such power? If time travel were to become a tool for societal elites or even nations with unchecked power, the consequences could be devastating, as history itself could be bent to serve narrow interests, creating a distorted reality. The idea of temporal exploration offers both a profound vision of humanity's potential and a cautionary tale of the perils of meddling with time. Time travel could grant us extraordinary new tools for progress, understanding, and growth, allowing humanity to rewrite history and guide the future. However, the risks involved, unpredictable consequences, paradoxes, and moral dilemmas suggest that such power might be too dangerous to wield without profound consideration. As we continue to explore the theoretical possibilities of time travel, we must grapple with the question: can humanity responsibly manage the ultimate frontier, or would the very act of altering time's course risk our destruction? Temporal colonization. Could time travel be the answer to overpopulation? As humanity faces the growing crises of overpopulation, resource depletion, and climate change, the speculative idea of using time travel as a solution has captured the imagination of some thinkers. Could time travel be the key to overcoming the existential threats that our planet faces? By traveling to different points in time, might we be able to ease the pressure on our resources, relocate populations to alternate futures, or even borrow solutions from more advanced civilizations? While this concept might sound like the plot of a science fiction novel, it raises interesting questions about the potential and the perils of manipulating time to resolve global crises. The utopian vision of temporal colonization, the allure of time travel as a solution to overpopulation, is clear. With the world's population continuing to grow, many experts predict that by 2050 the global population will exceed 9 billion. This surge in numbers places immense strain on food, water, housing, and energy resources and accelerates environmental degradation. Time travel offers a tempting alternative to simply managing the crisis in the present. If humanity could travel to the future, perhaps we could relocate some of the overpopulated areas of the world to times or places where resources are abundant, or where human ingenuity has solved the problems we face today. In this idealistic vision, time travel could function as a form of temporal colonization, allowing us to escape the pressures of the present by inhabiting new periods of time where civilization has already thrived. Similarly, temporal colonization could help alleviate the strain on Earth's environment. If time travel allowed us to harvest technologies or knowledge from the future, solutions to energy, climate change, and resource scarcity, humanity could jumpstart sustainable practices that would otherwise take centuries to develop. It's a utopian idea, time travel as a way to sidestep our current limitations by skipping to a future where solutions to the problems we face have already been found. In addition to these practical uses, time travel could provide an escape from the ecological disasters caused by overpopulation. By relocating to times where populations are smaller and nature is more resilient, we could theoretically preserve Earth's delicate ecosystems, giving the planet time to heal while humanity explores new temporal frontiers. The flaws and dangers of temporal colonization. However, the idea of using time travel to solve global crises is not without its significant flaws and risks. First and foremost, altering the course of time could have catastrophic unintended consequences. Even if we could travel to a future where resources are plentiful or where environmental damage has been reversed, the act of moving populations through time could destabilize timelines and cause paradoxes. The butterfly effect suggests that even the smallest changes in the past or future could trigger unpredictable and potentially disastrous consequences. A single decision made in the present could drastically alter the future in ways we cannot foresee, potentially making things worse instead of better. Moreover, the idea of borrowing solutions from the future could be deeply problematic. What if the solutions we encounter are not applicable to the present? Or worse, what if the future we encounter is not as utopian as we imagine? There's a real danger in assuming that future societies will have solved our problems, particularly if those future societies face their own set of challenges. Future civilizations might have already suffered from the effects of overpopulation, resource depletion, or climate change, just on a different timeline. In fact, by relying too heavily on future knowledge, we risk neglecting the necessity of creating our own sustainable solutions in the present. Additionally, time travel itself could exacerbate the very issues it seeks to resolve. The ability to escape to different times could become a form of societal retreat, with the most privileged using time travel as a means to escape the present instead of working to fix the problems at hand. If certain groups or nations gained access to time travel, they could leave behind the most vulnerable populations, deepening inequality and creating new divisions. Instead of solving the crises of overpopulation, resource depletion, and climate change, temporal colonization could intensify global tensions and inequalities. Finally, the ethical implications of moving populations through time raise significant concerns. Who decides who gets to travel to the future or the past? Should we allow certain populations to relocate while others remain behind, dealing with the consequences of today's actions? Temporal colonization could easily be used as a tool for exploitation, with the rich and powerful bending time to their advantage, while the disadvantaged are left to bear the consequences of their choices. While the idea of using time travel to alleviate overpopulation and environmental crises presents an intriguing utopian vision, it is fraught with risks and challenges. The potential for unintended consequences, ethical dilemmas, and societal division means that temporal colonization could exacerbate rather than solve the problems it seeks to address. Instead of relying on speculative technologies, humanity must confront the realities of today's crises with practical, sustainable solutions. Time travel, if ever possible, should not be seen as an escape but as an opportunity for deeper reflection on our responsibilities to the present and future generations. The cosmic significance of time. Time travel is often viewed through the lens of personal or societal benefit, escaping tragedies, revisiting moments of significance, or altering history for the better. But what if we broaden our perspective to consider time travel on a cosmic scale? How does the ability to traverse time fit into the grand tapestry of the universe, and what role might it play in humanity's ultimate destiny? Time travel, when viewed in the context of the cosmos, presents both profound possibilities and unsettling implications, especially when contrasted with the more immediate, personal motivations that often dominate our perception of time, travel, and the cosmos on a cosmic scale. Time travel could offer humanity a means to transcend the limitations imposed by both space and time. The vastness of the universe, with its billions of stars and galaxies, presents an intimidating backdrop for human exploration. Space travel, as it exists today, is constrained by the speed of light, making journeys to distant stars or even other galaxies impractical. However, time travel could, in theory, provide a way to skip ahead to epochs where humanity has evolved, established colonies, and mastered the universe in ways unimaginable today. From the cosmic viewpoint, time travel could be the ultimate tool for interstellar civilization, a way to bridge the vast temporal distances between now and an infinitely distant future, where advanced civilizations might be able to manipulate space, time, and energy at will. The role of time travel in the larger cosmic picture could also involve the exploration of the universe's past. By traveling backward, we could observe the origins of the universe itself, witnessing the Big Bang, the formation of stars, and the emergence of life. These observations could reshape our understanding of cosmic history and the fundamental forces that govern existence. Time travel could be the key to unlocking the mysteries of the universe, providing humanity with a front-row seat to the unfolding of cosmic events, not just from a distance, but from within the flow of time itself. Moreover, time travel could allow us to witness the ultimate fate of the cosmos from the distant future, where stars burn out and black holes consume entire galaxies, to the heat, death of the universe, or the potential for rebirth in a new cosmic cycle. From this broader viewpoint, time travel takes on an existential significance. It's not just about manipulating personal or historical moments, but about positioning humanity within the vast, unfolding story of the universe. Could time travelers one day journey to the end of time, learning whether the universe has a purpose or destiny, or whether it is merely a random cosmic accident? The narrower view of personal time manipulation, in contrast, Personal time manipulation, the ability to revisit one's own past, alter personal decisions, or peer into the future, presents a more narrow, immediate perspective. While these abilities can seem alluring, they ultimately raise questions about free will, determinism, and the nature of identity. Personal time manipulation focuses on the individual's relationship with time, often reflecting a desire for control over one's fate. The personal motivations behind time travel tend to center on fixing mistakes, avoiding pain, or reliving moments of happiness. The cosmic picture, on the other hand, requires stepping back from personal desires to consider humanity's place in the grander scheme of the universe. On a cosmic scale, the focus shifts from individual desires to collective human destiny. While individuals might be tempted to manipulate time for their own benefit, the broader question becomes, what is the purpose of humanity's existence in the vast temporal continuum? The cosmic perspective highlights the temporal insignificance of individual moments in the grand sweep of time, urging humanity to look beyond personal gain and to think about the long-term consequences of tampering with time, cosmic time travel, and human destiny. From a cosmic perspective, time travel might also illuminate our role in the larger story of existence. If humanity is capable of manipulating time, it could potentially play a role in shaping the fate of the universe itself. Will time travelers from the future guide humanity through pivotal moments, helping us avoid existential threats, or will they watch as we falter and face the same challenges that doomed other civilizations in the cosmos? Time travel could ultimately provide humanity with a form of cosmic agency, allowing us to not only explore time, but to become active participants in the unfolding of universal history. However, with this power comes great responsibility. The ability to change time could disrupt the delicate balance of universal events, potentially creating unforeseen consequences on a cosmic scale. In conclusion, while time travel on a personal level may address immediate desires and dilemmas, its cosmic significance is far more profound. Time travel, when considered in the context of humanity's larger role in the universe, challenges us to reflect on our destiny, purpose, and place within the infinite continuum of time. It forces us to consider whether the manipulation of time is merely a tool for individual gain or if it holds the potential to define the future of human civilization itself. As we look to the stars and contemplate the possibilities of time travel, we must balance our personal desires with an awareness of our responsibility to the cosmos. The concept of free will in a time-traveling world, time travel, if ever realized, would present profound philosophical dilemmas, particularly concerning the concept of free will. If we could travel through time, whether to alter the past, glimpse the future, or shift timelines, what does that mean for our ability to make choices? Are we the masters of our destiny, or is time a predetermined chain of events that we cannot escape regardless of our actions? Philosophers have long grappled with questions of free will versus determinism, and the introduction of time travel complicates these debates, offering new perspectives on fate, choice, and responsibility. The predestination argument: is time already set? One of the most pressing philosophical questions time travel introduces is the possibility that time is fixed and that free will is merely an illusion. If time travel were possible and we could travel backward or forward, we might learn that our actions have always been part of a predetermined sequence. The notion of a block universe, championed by philosophers like McTaggart and physicists in the context of relativity, suggests that all points in time, past, present, and future, are equally real and unchanging. In this view, the timeline is like a book with all the pages written. No matter how we try to alter it, the plot has already been established. For example, a time traveler who goes back to prevent a tragic event, like an assassination, might find themselves in a situation where they are compelled by events or unforeseen circumstances to allow it to happen. In this case, time travel itself could become part of the plan to ensure that the future unfolds as it is meant to. The idea here is that no matter how much we try to influence events, the timeline is set, and all actions, including the ones we perceive as choices, are inevitable. This deterministic view raises the question: if time is predestined, do we truly have free will? The famous butterfly effect in chaos theory suggests that even small actions can lead to vast changes, but in a predestined world, those changes might be part of the grand design. Time travelers, in this view, would be like characters in a book, seemingly autonomous yet bound by the narrative. The free will argument: can we change our fate? On the other hand, if time travel were possible, it could open the door to true free will, suggesting that we can indeed change the course of our lives and the universe. If the future is not fixed and can be altered by our actions, then free will would play a significant role in how time unfolds. This perspective aligns with the idea of open future in philosophy, where the future is not predetermined and we have the ability to shape it through our decisions. In this framework, time travel might be seen as a tool for exploring alternate outcomes rather than a mechanism that confirms fate. A time traveler who changes a historical event might create a branching timeline, an entirely new path in the continuum of time where different possibilities emerge. In this case, the notion of free will aligns with the idea of a many worlds model in quantum mechanics. Every decision and action creates new possibilities and diverges into different realities. Time travel, far from being a force of inevitability, could amplify human agency, allowing individuals to explore various outcomes and assert their autonomy across different timelines. For those who believe in free will, time travel could be an opportunity to take control of one's destiny, test different choices, and observe the consequences. The traveler could continuously change course, re-evaluating their decisions and opting for better outcomes based on the knowledge they gain from traversing different moments in time. This presents a fascinating view of free will, where individuals are not constrained by the current moment, but empowered to continuously shape their future and learn from their past actions. The middle ground, compatibilism and time travel. Another philosophical stance on free will and time travel might be compatibilism, the belief that free will and determinism are not mutually exclusive. In a time-traveling world, compatibilists might argue that while time could be fixed in some sense, the laws of physics creating a determined flow of events, human beings still exercise free will within those constraints. In other words, even if events in the universe are predetermined in some way, humans can still make meaningful choices within that framework, and time travel would not erase the importance of human decision-making. For example, even if a time traveler finds themselves in a predetermined timeline, their ability to make moral choices, whether to intervene in a historical event or let it unfold, still constitutes an act of free will. While the larger flow of time might be constrained, the individual's capacity to choose still exists within the framework of their actions and consequences. The relationship between free will and time travel is complex, and different philosophical viewpoints offer unique answers to the question of whether we can change our fate. Whether time is predestined, open to change, or somewhere in between, the concept of time travel forces us to reconsider our role within time itself. As we imagine the possibilities of traveling through time, we are also forced to confront deeper questions about autonomy, responsibility, and our place in the vast continuum of existence. Time travel, in its speculative form, ultimately challenges us to rethink the very nature of choice, fate, and the human condition. The illusion of time. Philosophical perspectives. Time has always been one of the most fundamental concepts in human experience, yet philosophers and scientists alike have debated its true nature for centuries. Is time a real, objective force that governs the universe? Or is it simply an illusion, a construct of the human mind? This question has profound implications for how we understand reality, existence, and our place in the cosmos. In this section, we'll explore the philosophical debate surrounding the reality of time, contrasting scientific explanations with existential and phenomenological perspectives. Scientific views on time, objective and measurable from the standpoint of modern physics. Time is an objective, measurable dimension that plays a crucial role in the structure of the universe. Albert Einstein's theory of relativity revolutionized our understanding of time by showing that it is intertwined with space in a four-dimensional continuum known as space-time. In this framework, time is not a fixed, absolute entity, but is relative, changing depending on the observer's speed and gravitational field. This means that time can be experienced differently by different observers, with time dilation causing time to slow down for objects moving near the speed of light or in stronger gravitational fields. For physicists, time is not an illusion, but a critical component of how we experience the world. It is a dimension, like space, in which events occur and are sequenced. The precision with which we can measure time, from atomic clocks to the synchronization of satellites, underpins much of modern technology. In this sense, time seems to be an undeniable feature of the universe, something that exists independent of human perception. However, even within the scientific community, time's true nature is still a subject of debate. While relativity treats time as a real, albeit flexible, dimension, quantum mechanics presents a different view. In quantum theory, time appears less certain, and the conventional flow of time doesn't always apply. Some quantum interpretations, like the many worlds hypothesis, suggest that time could be a more fluid concept, with parallel timelines and alternate realities branching off from one another. Here, time's continuity and direction are called into question, suggesting that what we experience as time may not be as objective as it seems. Existentialism and time. A human construct. From an existentialist perspective, time is often viewed as more of a mental construct than a concrete external reality. Thinkers like Jean-Paul Sartre and Martin Heidegger challenged the traditional scientific conception of time, arguing that it cannot be separated from the human experience of being. For existentialists, time is not something that exists independently of human consciousness. Rather, it is a way in which we interpret and structure our experiences. Heidegger, in particular, distinguished between two kinds of time: clock time, which measures the passage of events, and lived time, which refers to the subjective, personal experience of time. Sartre, influenced by phenomenology, emphasized the human tendency to perceive time as a series of linear moments. We are constantly aware of our past, present, and future, which creates a sense of temporality. But Sartre also saw this perception of time as something that alienates us from our true existential nature. The anxiety we feel about time, the pressure to live in the present, to move toward a future goal, or to escape from the past, becomes a central part of the human condition. From this perspective, time is a source of existential dread, but it also shapes our ability to make choices and live authentically. Phenomenology. Time as lived experience. Phenomenology, a philosophical movement founded by Edmund Husserl and expanded by Heidegger, offers yet another view of time. In phenomenology, time is deeply connected to the way we experience the world. Husserl distinguished between objective time, the time measured by clocks and instruments, and subjective time, which is how we experience the flow of events in our consciousness. According to phenomenology, our perception of time is inseparable from our experience of being in the world. It's not an abstract concept, but something we feel, live through, and act upon. In phenomenological terms, time is not just an external force, but an internal experience that is shaped by our consciousness. For example, the way we experience time can be altered by our emotional state, attention, or context. A moment of joy may feel timeless, while periods of anxiety or dread can stretch time out indefinitely. This suggests that time is not a fixed, measurable entity but a fluid, subjective experience that arises from our ongoing engagement with the world around us. The illusion of time. A radical, but finally, some philosophical traditions, especially in Eastern thought, suggest that time is an illusion altogether. Buddhist philosophy, for example, teaches that time is a mental construct, a product of the ego that prevents us from seeing reality as it truly is. The experience of time in this view is tied to our attachment to the self and our constant striving to achieve, possess, and control. The ultimate goal of many spiritual traditions is to transcend this illusion of time and realize the eternal present, where the past and future cease to exist, and only the now remains. Whether time is real or an illusion depends on the perspective from which we approach it. From the scientific viewpoint, time is an objective and essential feature of the universe, essential to understanding the laws of physics and the fabric of reality. Yet, from existentialist and phenomenological perspectives, time becomes more of a human experience, a lens through which we make sense of our lives. Time in these philosophies is a product of consciousness, a construct that shapes our existence, but is not necessarily a fixed entity. Ultimately, the question of whether time is real or illusory invites us to reconsider not only how we view time, but how we live with it, experience it, and make sense of our own place in its ever-moving flow. The eternal now. Can time travel offer immortality? The concept of immortality has fascinated humanity for millennia, often depicted in myths, religious texts, and works of fiction. With the advent of time travel in speculative thought, the idea of transcending death and living forever takes on a new dimension. If we could manipulate time, could we achieve immortality? Could time travel offer a way to bypass death, allowing us to revisit the past, relive our lives, or even live indefinitely by jumping to different points in time? While such a concept seems to promise eternal life, it also raises deep philosophical questions about the value and meaning of life itself. Time travel as a path to immortality. The idea that time travel could lead to immortality often involves the ability to revisit key moments in one's life or to journey to the future, where advanced technology might offer solutions to aging and death. One possibility is the idea of looping through time, returning to a point before death occurs, essentially reliving one's life in perpetuity. If a person could continually return to their past, death could be avoided, offering an infinite number of second chances. Alternatively, time travel could allow someone to step into the future, finding an era where medical breakthroughs, such as the ability to halt aging or regenerate tissue, have led to a form of biological immortality. In this context, time travel could theoretically offer a means to escape the natural limitations of the human lifespan. By stepping into a future where death has been conquered, humanity might bypass the necessity of dying at all. With access to advanced future knowledge, individuals could constantly regenerate, repair, or enhance their physical and mental states, extending life indefinitely. The existential dilemma of immortality. While the prospect of immortality through time travel might seem appealing, it raises profound existential and philosophical questions about the nature of life and death. One major consideration is the question of whether immortality would actually be desirable. Human existence is inherently finite, and part of what gives life meaning is the knowledge that it will end. If death were no longer a defining feature of existence, would life lose its sense of urgency, purpose, and value? Existentialist philosophers like Jean-Paul Sartre and Martin Heidegger argue that it is precisely the awareness of death that imbues life with meaning. The fleeting nature of existence forces us to confront our mortality and makes each moment precious. If time travel could grant immortality, would our lives still feel meaningful, or would they become a never-ending cycle of repetition, devoid of purpose? Living forever might reduce the significance of individual moments, as there would be no ultimate endpoint to guide our decisions and shape our actions. Moreover, immortality through time travel could bring unintended consequences. Would the experience of living forever lead to existential boredom or despair? How would individuals cope with the loss of loved ones as they age, while their own bodies remain the same? The emotional toll of losing relationships, witnessing the passing of entire civilizations, or feeling disconnected from the natural cycle of life and death could outweigh any benefits. In fact, the idea of living forever might become a form of existential prison, trapping individuals in an eternal now, where they are denied the catharsis and closure that comes with mortality. The paradox of living forever. Additionally, the very concept of immortality through time travel introduces a paradox. If time is truly malleable, then the idea of living forever becomes murky. If we could simply jump to different points in time, experiencing various versions of our life, would we even be living the same life, or merely existing across multiple realities? The experience of immortality would no longer be a singular, cohesive journey, but a fragmented sequence of moments, potentially stripping away the narrative continuity that gives life its meaning. Without the natural progression from birth to death, we might lose the very essence of what it means to be human. Furthermore, the power to transcend death through time travel raises questions about the ethics of immortality. Who gets access to such power? Would immortality be restricted to an elite few, creating a class divide where only the wealthy or powerful could escape death? The societal ramifications of such a capability would likely be profound, potentially leading to inequalities and conflict, as those who are not granted immortality might be left to face the inevitable end of their lives alone. While time travel offers a tantalizing prospect of immortality, it also forces us to confront the deeper questions of what it means to live and die. Immortality might grant us the ability to bypass death, but it could also strip away the very essence of life's meaning, making existence feel less authentic, more mechanical. Life's temporal nature, the inevitable passage of time, imbues each moment with significance, and without death, we might lose the urgency and emotional richness that define the human experience. Ultimately, the question remains, is immortality, even through the lens of time travel, truly a gift, or is it a curse that robs us of the very experiences that make life worth living? Could time travel rewrite the future? 500 words. The possibility of time travel introduces an unprecedented power, the ability to rewrite the future. If humanity could manipulate time, could we reshape the course of events, altering the trajectory of history in ways previously unimaginable? This notion evokes a profound sense of agency, suggesting that we could take control of our destiny, erasing past mistakes, preventing catastrophes, or guiding society toward a utopian future. But such power raises deeper philosophical questions about fate, free will, and the very nature of time itself. Could time travel truly allow us to rewrite the future, or are we bound by forces beyond our control? The vision of a rewritten future, time travel offers a tantalizing opportunity to intervene in the future before it even happens. Imagine being able to see a future where society is plagued by war, environmental collapse, or social injustice, and then traveling to the past to change the pivotal moments that led to such outcomes. Through this lens, time travel becomes a tool for shaping the future, a way to actively steer humanity away from disaster. By making different choices at critical junctures in history, we could rewrite the script of civilization, creating a future where humanity thrives and overcomes its greatest challenges. This vision of time travel as a means of rewriting the future holds immense appeal. It places humanity in the driver's seat, empowering us to choose the path forward without the constraints of fate or destiny. By preventing catastrophic events, correcting mistakes, or facilitating breakthroughs, time travelers could shape a future defined by progress, peace, and prosperity. Fate versus free will. Can we control time? However, the ability to rewrite the future through time travel introduces a fundamental philosophical dilemma: the tension between fate and free will. If we can alter the course of events, does that mean the future is malleable, subject to our choices and actions? Or does time follow an inevitable, predetermined course where any attempt to change the future only leads to the same outcome? From a deterministic perspective, time is a fixed, unalterable sequence of events governed by the laws of cause and effect. In this view, even time travel cannot change the future because the future is already written, and no matter how many times we intervene, the timeline will always revert to its predetermined course. This is known as the fixed timeline theory, where actions taken by time travelers are part of the established flow of time, and any attempts to alter history simply lead to the creation of the future that was always destined to unfold. The multiverse theory offers a different approach. According to this perspective, time travel could create new timelines, branching off from the original path. Each choice made by a time traveler results in a divergence, creating alternate versions of reality where different outcomes emerge. In this scenario, rewriting the future is possible, but only by creating entirely new realities with their own futures. The challenge, then, is not about changing one unified timeline, but about navigating an infinite web of possible futures, each with its own potential consequences. Meanwhile, in the realm of free will, time travel allows for the possibility of agency and choice. The future, from this perspective, is not set in stone but exists as a vast expanse of possibilities, waiting to be shaped by human decisions. If time travel grants the ability to visit different moments in time, humanity would have the power to learn from the future, correct its course, and proactively influence events. In this way, time travel becomes a tool for the exercise of free will, enabling us to create new outcomes and build the future we desire. The dangers of rewriting the future. Yet, while the power to rewrite the future seems liberating, it comes with significant risks. The unpredictability of time is a fundamental challenge. Even well-intentioned interventions could create unforeseen consequences, leading to new problems that are just as severe, if not worse, than the original ones. The famous butterfly effect suggests that even small changes in the past could trigger cascading impacts, creating an entirely new set of challenges. In this sense, time travel could become a double-edged sword where attempts to control the future end up spiraling out of control, creating a paradoxical loop of unintended outcomes. Furthermore, the ethical implications of rewriting the future must be considered. Who decides what the right future should look like? If time travel allows for the alteration of events, who holds the moral responsibility for shaping the course of history? Is it possible to determine what constitutes a better future without imposing a specific vision of society on others? The idea of controlling the future raises concerns about the abuse of power, as those with the ability to manipulate time could impose their own values, potentially erasing the diversity of human experience and the freedom of future generations. In the end, the question of whether time travel can rewrite the future invites us to reflect on the nature of destiny, choice, and responsibility. While the power to alter the future offers an alluring sense of control and agency, it also forces us to confront the complexities of causality, free will, and ethics. Time travel, as a tool for rewriting the future, may offer vast possibilities, but it also reminds us that the future is not something we can simply dictate. It is a delicate balance of decisions, consequences, and the ever-changing flow of time. Ultimately, time travel challenges us to consider whether the future should be controlled or allowed to unfold organically, shaped by the choices we make today. The role of time in the grand scheme of existence. Time, as both a concept and a dimension, plays a central role in shaping the universe and our understanding of existence. The idea of time travel invites us to reconsider its role in the grand narrative of the cosmos, challenging our perceptions of causality, destiny, and human meaning. If we could truly manipulate time, what would that mean for the universe itself? How would our ability to travel through time fit into the vast and intricate story of existence? And perhaps more profoundly, how do these possibilities contrast with the limits of human understanding? Time and the cosmic order, the universe as we know it, operates according to the principles of time, space, and the laws of physics. From the birth of the cosmos in the Big Bang to the eventual heat death of the universe, time governs everything. The life cycles of stars, the evolution of galaxies, and the unfolding of life on Earth. In this grand narrative, time is a relentless force, progressing in one direction and organizing the events of the universe into a linear sequence. Time travel, if possible, would fundamentally alter our relationship to this progression. In a cosmic sense, time travel could serve as a means of interacting with the universe at a deeper level, allowing us to explore the past and the future. It would allow us to witness the formation of galaxies or the collapse of stars, and perhaps even to glimpse the end of time itself. If humanity could manipulate time, we might gain access to the ultimate mysteries of the universe, understanding not only the laws of physics that govern time, but also the deeper existential questions about the purpose and meaning of life in a universe that is constantly changing. Yet this potential power would also raise questions about the role of humans in this cosmic story. Time travel might allow us to intervene in events, but would we be altering the grand design of the universe, or would we merely be taking our place within it, playing out a preordained role? The ability to travel through time could create a sense of cosmic agency, but it could also challenge our understanding of the universe as a meaningful, unfolding process. If we were to alter time, would we disrupt the natural order of existence or simply participate in a larger cyclical pattern of events? The limits of human understanding. Despite the allure of manipulating time, there are limits to our understanding of both time and the cosmos. As humans, we are bound by the limitations of our perception, and the concept of time is something that is deeply ingrained in our everyday experience. Time, as we know it, is measured in seconds, minutes, and hours, units, that reflect our individual and societal needs. But beyond our immediate experience, time becomes more abstract, especially when considering the vast scales of the universe or the complexities of theoretical physics. The nature of time itself remains elusive. In physics, time is often treated as a continuous measurable dimension, but its true nature is still debated. Theories like relativity and quantum mechanics have shown that time is more malleable than we once thought, but they also highlight the complexity of time's relationship to space and matter. Time may be a fundamental aspect of the universe, but it is also deeply entwined with our perception of reality. When we consider time travel, we are forced to confront the limits of human comprehension. Can we truly understand time as a dimension outside of our personal experience? Or are we forever constrained by our limited perspective? The very idea of manipulating time raises profound questions about the extent to which humans can control or even understand the universe. Time travel, while a fascinating concept, might reveal the fundamental limitations of our consciousness, forcing us to confront the possibility that the universe and its unfolding story is far beyond our comprehension. The cosmic and human scale of time. In the grand scheme of existence, time is both a driving force and a profound mystery. Time travel offers the tantalizing possibility of exploring the universe's past and future, giving humanity the chance to grasp the larger narrative of the cosmos. However, this potential power forces us to confront the limits of our understanding, suggesting that our perception of time is but a small piece of a much larger, incomprehensible whole. The true meaning of time and its place in the grand story of existence may remain elusive, forever beyond the reach of human comprehension. As we continue to explore the possibilities of time travel, we must recognize that our role in the cosmic timeline is just one part of a vast and ever-evolving process. Whether time is a fixed sequence or a fluid concept, it remains the thread that ties all of existence together, from the birth of stars to the potential collapse of the universe. The power to manipulate time, if ever achieved, would allow us to engage with this cosmic story, but it may also reveal how little we truly understand about the universe's ultimate meaning. Embracing the paradox of time. As we draw the journey of time travel to a close, it's clear that the concept offers both extraordinary potential and profound dangers. Throughout this exploration, we've ventured through the realms of possibility, delving into how time travel could reshape the future, transcend death, and even allow us to manipulate the very course of existence. Yet, with every tantalizing opportunity to rewrite history, we've also encountered the paradoxes and philosophical dilemmas that challenge our understanding of time, free will, and destiny. Time travel opens up immense possibilities for humanity. The ability to undo mistakes, explore alternate realities, and perhaps even create a more just and prosperous future. It offers us a kind of cosmic agency, an opportunity to step beyond the confines of our moment and into the vast expanse of time itself. With time travel, we might step into the distant past to witness the formation of stars, or travel forward to observe the evolution of civilization, potentially gaining wisdom from futures that have already unfolded. The allure of this power is undeniable, and it calls on us to imagine a future where humanity can transcend the limitations of space, time, and even mortality. However, as with all great power, the dangers of time travel are just as profound. The potential to alter the course of history presents us with questions about the very nature of free will, fate, and the ethical implications of meddling with the fabric of time. Could we truly control the future? Or are we bound by the inescapable constraints of a fixed timeline? The paradoxes of time travel, such as the grandfather paradox and the butterfly effect, reveal how fragile our understanding of time really is. Every action we take in the past, no matter how small, could send ripples through the present and future, leading to unintended consequences that we are ill-prepared to navigate. Perhaps most importantly, time travel challenges our fundamental understanding of existence itself. What is the meaning of life if we could rewrite our story, relive moments indefinitely, or escape the inevitability of death? Would immortality through time travel rob life of its urgency and beauty? Philosophical perspectives, from existentialism to phenomenology, suggest that it is our mortality and the finite nature of time that give our lives meaning. If we had the power to bypass these limitations, would we still find value in the experiences we cherish most, or would the infinite repetition of moments dull their significance? Ultimately, time travel forces us to confront not only the vastness of the universe and the possibilities of the future, but also our own place within time. We are beings of momentary existence, caught between the past and the future, struggling to make sense of the transient nature of our lives. Time, whether it is an illusion or a fundamental force of the universe, shapes our identity, choices, and experiences. We are all travelers through time, whether we acknowledge it or not. The question is, how do we choose to live in this moment, knowing that time is both a precious gift and an unyielding force that will continue long after we are gone? So, as we conclude this exploration of time travel, I challenge you to reflect on your own place in time. What would you do if you had the power to change history or glimpse the future? Would you try to rewrite your own story, or would you embrace the beauty of the fleeting present? Time may be a paradox, elusive and ever-moving, but it is also what makes us human. The future is not yet written, and while we may never have the power to control time, we do have the power to choose how we experience it. And perhaps, in that choice, we hold the key to shaping our future, one moment at a time.